probabilities from here to there. That's what this is what this means. Find the probabilities from here to there. Okay, so I want to extend this. Okay, make it bigger. And so what does it really mean to find the probabilities from 0 to 4? Because the sign given to us is less than or equal to. In other words, we are told to accumulate from 0 to 4. We can do it individually. We can say P0. We find P0, and P0 stands in as n combination 0, success to power 0, failure to power n minus 0. P1 is n combination 1, success to power 1, failure to power n minus 1. And P2 is n combination 2, success to power 2, failure to power n minus 2, until you get to 4. So the next one is P3, and I'm going to clear this. So P3 will be n combination 3, success to power 3, failure to power n minus 3. So you can do it individually. And the last one is P4. P4 is n combination 4, success to power 4, and failure to power n minus 4. Okay, so we are going to do the calculation. All right, we're going to do the calculation. You can use your calculator to do it. But I'm going to use my calculator. I will do n binomial probability distribution, binomial. Why binomial? Because all the properties of this question, and I'm also told it's binomial. So binomial cumulative density function. And the argument is n, comma, probability of success, comma, and x. So, and I can rewrite it as binomial CDF, binomial PDF. This time I am accumulating CDF. Binomial CDF. What is n? N is 12, comma, success is 1.1%, 0.1, and random variable is 4, starting from 4 down. So I'll pull up my calculator and calculate this. Pull my calculator up and calculate that. So I am calculating the total probability using my calculator. So pull the calculator up. Go to binomial distribution. And where do I see binomial distribution? Second distribution. I'm looking for binomial, not normal. Some people go to find this. No, this is normal distribution. You're not looking for normal distribution. You're looking for binomial. So I'm going to arrow up. And I'm looking for binomial cumulative density function. So it is B. I'll select B. And it's asking me what is the number of trials. In other words, what is n? The number of trials is 12. And then what is the probability of success? 0.1. What is the value? What is the random variable? 4. And I'm going to tell my calculator to calculate. And it's asking me, is that what you want me to calculate? Yes. So the probability to 3 decimal places, the probability of accumulating from 4 to 0 is 0.996. The probability of x such that x is less than or equal to 4 is 0.996 to 3 decimal places. If I'm told to write my answer in percent, it's 99.6%. If I'm told to write my answer in percent, it's 99.6%. Okay. You can be told to do it by hand. It means you find P0 plus P1 plus P2. You add them all together and then find the answer. Or you could be told to make a table. If you're told to make a table, then you have to make a table. You can be told to make a probability distribution table. So, all right, so now, all right, so that's one binomial distribution question. So we go back to the worksheet and look for another binomial distribution question. So we look, let's go to, I think number 18 is binomial distribution. Okay, so number 18 is binomial distribution. A binomial probability experiment is conducted with the given parameters. Compute the probability of X successes in n independent trials of the experiment. Okay, so this is, let me see, do I have any question? All right, do you have any? Savannah, do you have any question? Any question? All right, so I'll go back to, I want to make sure that you don't have any question. So I'm just going to go back to the practice test. So we are working on binomial distribution. Want to make sure we understand binomial distribution. This is number 18. I am told that it's a binomial distribution. So number 18, a binomial probability experiment is conducted with the given parameters. Compute the probability of X successes in the n independent trials. Okay, so what I'm going to do is find what n is. N is given to me to be 10. Probability of success is 20% or 0.2. If probability of success is 20%, then failure will be 1 minus 0.2, which is the same as, and then the random variable X is equal to 2. Whenever it is equal to, I am doing binomial PDF. So, but suppose I'm told to put this in my in the formula. I'm going to put it in the formula so we know that we can do it with the formula. So I'm going to do it with the formula now. First of all, I'm going to put it in the formula. So remember that the formula is n combination R or X, success to power R, and failure to power n minus R. If I use the formula that I'm given, n is 10 combination R, and R is the number at a time. I can call it success to power 2. And let me put this success in decimal. So the success given to me is 0.2. So I have 0.2 to power 2. And if success is 0.2, failure is 0.8. 0.8 to power 10 minus 2. 10 minus 2 is 8. So I have put this in my formula. In the formula, I can calculate it with formula. Then also calculate with the calculator. So if I'm using the calculator, I'll do binomial PDF because it's a single probability. That's why I'm doing binomial PDF. The argument is n, comma, success NPR. So P is probability of success. R is the random variable. Let me put it here, binomial PDF. Sample size is 10, comma, success is 2%, 20%, and the number at a time, which is the random variable, is 2. I'm going to evaluate this one and also evaluate this one. So the first one I want to evaluate with my calculator is the second one. Okay. So the first thing I want to do is turn my calculator on, go to second distribution. Remember, this is binomial. It is not normal. So I'm going to binomial PDF. Binomial PDF. Number of trials is sample size. What is the probability of success? 0.2. What is the number I want to take at a time? It is 2. Paste means calculate. So I'm going to calculate. And it's asking me, is this what you want? Yes. So I'm calculating this. Therefore, using my calculator, the probability of x greater, less than or equal to 4 is equal to, remember that this probability, your answer cannot be up to 1, cannot be greater than 1. So 0.301. The probability of cumulative 4 plus 3 plus 2 plus 1, 3. I'm going to do the same thing with calculator. Let me see. Is it going to be the same answer with, so the one I put in my formula sheet, I'm going to also evaluate that. So how do I put this in my calculator? I already know that combination is probability. So 10 combination 2. So I put 10, go to math, arrow to PRB, combination is number 3, combination 2, and then I multiply it by success. What is the probability of success? Is 0.2 to power 2, and then multiply by failure. Failure is 0.8. 0.8 arrow. If I caret, it is 8. That's 10. That is 10 minus 2. Okay. When I hit enter, I want to see if my answer by calculator. So it doesn't matter which way you do it. If you do it by calculator, you get the same answer. If you do it by the shortcut, you get the same answer. This is by a formula. This is by shortcut. Okay. So now let's go to, we have done 2 questions on binomial. So we're still working on chapter 6. Working on chapter 6 so that next week we get into normal distribution. Okay. So I'm going to arrow down, go to find a question that is on, this is the practice test I put in there. The practice test is already in Blackboard. So I'm looking for a question in discrete random variable, discrete probability distribution. Okay, so this is a question on discrete probability distribution. I'm going to get another one. So I'll come back to this one later on. So whenever a question is in discrete probability distribution, okay, that's another one that is discrete again. Let's see. Okay, so I'm going to pick one because they actually look alike. So I'm taking number 7. So they, in number 7, they give me, in that number 7, so I'm going to clean that. So I'm going to clean this up. So I'm told to convert the table from frequency distribution to probability distribution. So that's actually what this question means. The question is asking you to convert the frequency distribution to probability distribution. Remember, we did it in Unit 1, but that time we called it the relative frequency distribution. But relative frequency is the same as probability. So I am going to convert this table right here, convert that table to frequency distribution. Okay, so I am actually going to write the table here also. So this is the table. This is X, the random variable. This is frequency. And there are 4 of them, 4, 5, 6, 7. And then I am given the number of occurrence. 4 occurred 19 times, 5 occurred 20 times, 6 20 times, 7 37 times. All right, I'm now going to make a probability distribution from a frequency distribution. Okay, so this is 4, random variable 4. And for 4, I need to find the total frequency from the frequency distribution. So this is going to give me 20 plus 20 plus 59. So I have 60. That's going to give me 96. So the sum of the probabilities of frequencies 96. So for random variable 4, the relative frequency or probability is 19/96. For the number 5, the relative frequency is 20/96 is the same as probability. For number 6, the relative frequency is the same as 5. For number 7, the relative frequency is 37 divided by 96. Okay, so the next thing I want to do now is I would like to convert the relative frequency in decimal. It will help a lot. So let's change it to decimal. And by the way, we can put it in our calculator. So let's put this in our calculator. Let me go to my calculator and put it in there. So I'll go to turn my calculator on. So approximately this is 0.197. So let's make it 0.2, approximately 0.2. The other one is 0.21. All right, so we are told to you're told to draw a bar graph, and that question doesn't mean histogram. So we're going to have here, is it? So let me pull my answer. Okay. Now I'm about to look at the probability is the last one. So the highest probability is the last one, and 0.39 So the first one is the smallest. We want to take that in. So it cannot be this because the first one is the smallest. It cannot be this also. The first one is the smallest. So let's pull it to the left here. Okay. Yeah, so the one that is the smallest, 0.2. So this is almost 0.2, almost 0.2. So that is actually the answer. This is the answer because even though this is the smallest, it is not 0.1, it's 0.2. So this is 0.2, 0.2, and so on. So C is the correct answer. What I'm trying to stress is that these are bars. They are not histograms. Why? Because it's a discrete probability distribution. It is a discrete probability distribution, so it is not, you cannot draw a histogram. You have to draw a bar graph. All right, so we are told to answer question C. Question C, you are told to find the mean of the probability distribution. Okay, so what you do is you already know that the random variables are in L1, the probabilities are in L2. You do one variable start as usual. So you go to start, arrow to calc, do one variable start. So L1, L2, calculate. I'm going to calculate. And from my answer, the mean is, and they told me to leave my answer to 1 decimal point. So my answer is 5.8. So the mean is 5.8. They also told me to find the standard deviation, and the standard deviation is 1.2. So they told me to find the mean is 5. Also, if they tell me to find the variance, I will square the standard deviation. Okay, so this is how you can solve discrete probability distribution. Okay. All right. All right. So this is a question in binomial, I mean, a normal distribution. Okay. So we can actually do one more question on binomial distribution. Let's see if we have another question on binomial distribution. This is another question on discrete probability distribution. So determine whether the distribution is discrete. We did it the other day. It says, is the distribution a discrete probability distribution? What this question actually is asking you, is the sum of all the probabilities equal to 1? Is the sum of all the probabilities equal to 1? We answered this question the other day. We want to answer it again. Okay, so all I do is add all the probabilities. So I can actually put it in my calculator. So I'll go to my calculator. If the sum of all the probabilities is equal to 1, I will continue to answer other questions. Otherwise, I will stop there. So I'm going to go to Start, Edit, and I would like L3 and L4. So I will put all my random variables in L3. So I have 0, 1, 2, 3, 4. And I actually go to L4 and put in the probabilities in L4. 0.21, enter. 0.35, enter. 0.14, enter. 0.08, enter. 0.22, enter. All right. Okay, so now my random variable is in L1, the probabilities are in L2. I actually want to do one variable start. Okay, so I go to start and one variable start of L3 and L4. You have to be careful. Tell your calculator where the random variable is, and tell your calculator where the probabilities is also. My probability is in L4, and I will calculate the one variable start. and it tells me that the mean is that, but I'm not looking for the mean. I'm checking that n is equal to 1. So n is equal to 1, which means it's a probability, it's a discrete probability distribution. And what does it mean? The sum of all the probabilities are equal to 1. And if I'm told to find the mean, and the mean is 1.75 to 2 decimal places, and the standard deviation is 1.44 to 2 decimal places. So it's not a big deal. It's not a big deal. What we're going to do is go back to that worksheet we did before. I want you to know that in this unit, our test will be on the 27th. Our test will be on the 27th of March. Okay, so I already put the practice test in Blackboard that way. That way you will make sure you're practicing. Okay, so we have done 6.1 and 6.2. Next week, we shall continue with 7.1 and 7.2, 7.3. I want us to actually do some 7.1 today, but let me pull up this and then we can continue next class. We have already done some 7.1, but let's look at it again. So we know we have done some of them. We have done some of 7.1. Let me pull that up. Okay, need to put the 7.1 okay, and then I have to get it from here, and that is normal distribution. I want to make sure we know how to calculate some of this normal distribution. Very important. Okay, so let's go to all right, so we want to answer this question, calculate the I'm going to erase. Okay, so I want to calculate the area between. So what I'm going to do, whenever I'm told to find the area between two points in a standard normal, first of all, draw a diagram. So from 0 to 1.28, 1.28 is on the right-hand side because it's positive. So I will shade the area and then get my calculator. Remember the argument? The argument is normal because this is normal CDF, because I'm looking for area starting from 0 and then at 1.28. The mean is 0, the standard deviation is 1. Then I pull up my calculator and enter it in my calculator. So I'm going to clear, enter this in my calculator. Where do I go? Second distribution. Number 2 is normal CDF. And it's asking me what is the lowest number. The lowest number is 0. The upper number is 1.28, upper bound. The mean is 0, the standard deviation is 1. So I'm going to calculate. When I calculate, the area between is approximately 4. So the area between 0, remember that the approximately 0.4, because remember that area cannot be negative. So area between is 0.3997. Okay, they didn't tell me the number of decimal points, so I can use 4 decimal points. So 0.3997. Remember, you can also read the chart. Okay, so this is area between. So let's do area to the right, just to remind us that we already know this. So let's do area to the right in number 5. It says find the area to the right of 2.4. So you draw a normal curve. First thing is to draw a normal curve and I want to show 2.4. 2.4 is positive, therefore it's on the right hand side of the mean. And so it means find the area from 2.4 to is equal to 2.4 to positive infinity. Don't forget that positive infinity can only be found by using 1.1 e to the power 99. So calculate the area. You calculate the area. How do I do that? I'll go to distribution again. Normal CDF because it's area under the normal curve. What is the smallest number? 2.4. What is the highest number? 1 e to the power 99. 1 e to the power 99. The mean is 0, standard deviation is 1. So I'm going to calculate the area now. It's asking me, is that what you need? Yes. So the area is 0.0082 to 4 decimal places. 0.0082, 0.0082 is the area to the right. Is the area to the right of 2.4. That's area to the right. What if I'm told to do number 6, area to the left? So if I'm told to do area to the left, then I draw a normal curve. All right, first one is to draw a normal curve. So area to the left of negative 0.46. Negative means that z is negative. It's on the left-hand side of the mean, negative 0.46. So I'm told to find the area to negative infinity. That's what it means. So I'm going to shade the area. Negative infinity is negative 1 e to the power 99. Okay, then the next thing is to calculate. Next thing is to calculate. So, I'm going to find normal CDF again. Go to second distribution, number 2. What number is the smaller? Negative infinity is smaller. Negative 1 e to the power 99. So e is under comma. E is under comma to the power 99. What is the upper number? It is negative 0.46. 0.46. And then the mean is 0, standard deviation is 1. So we calculate. So I have area to the left is 0.3228. 0.3328. Remember, that area cannot be negative. So negative 0.3328. So the area is negative, 0.3228. Area cannot be negative. Therefore, area of this section is 0.3328. The most important thing is that you know how to put in infinity. We did this before. You should know how to put in infinity. Okay, so let's go to, remember that, let's answer this question. What is the total area under the normal curve? Total area under that normal curve is 1. What percentage of area falls above the mean? If this is a normal curve and area is 1, then the mean divides the normal curve into 2 equal parts. Therefore, area to the right of mean is 0.5 or 1/2 or 50%. This is what percentage? So 50%. The area under the curve for a normal distribution is 1. That is correct too. The mean, mode, and median are all equal for a normal. Approximately, the area under the standard normal curve that lies within 2 standard deviations from the mean is 95. It's true. A distribution is said to be positively skewed if the mean falls to the right of the mean. No, it is mean falls to the right of the median, not mean and mean. Okay. Well, these are just simple questions, but I want to make sure you know it. All right, so look at this one. Sometimes you are given a diagram, a normal distribution that is drawn for you. You want to make sure it's not even, this is easier than the ones we have done. They just only told you to find the shaded area because they drew the diagram for you. So area to the right from 0 to 2.25. Here is area to the left from 1.27 to negative infinity. Here is area to the right from negative 1.87 to positive infinity. But when you're given this one, area in the two tails, be careful. All you need to see is that the value, the absolute value of the z-score here is 1.2829. This is 1.29 also. So all you need is calculate the area to the left, because area on that normal curve, the normal curve is symmetrical. So if this is 1.229 and this is 1.29, the area here will be equal to area here. And that's what I'm going to do now. Calculate the area to the left of negative 1.29 and then write the same area to the right. Okay, let's do that. Area to the left, by the way, is, remember, this is what you're going to tell your calculator, normal CDF. So I am going to tell my calculator, normal CDF, area to the left is negative infinity, 1e to the power 99. And then upper bound is negative 1.29. The mean is 0, standard deviation is 1. So I get my calculator and put everything in. So second distribution on number 2, the negative infinity is already here. And I am going to put in negative 1.29. So negative 1.29. And then the mean is 0, standard deviation is 1. I am going to calculate. So what is that area? The area is 0.098. I can make it 0.099. 0.099. And if it is 0.099 on the left, it's also 0.099 on the right, because the normal curve is symmetrical. 0.099, because the normal curve is symmetrical. The absolute value of the z-score on the left and the right are equal. Therefore, the area to the left will be equal to the area to the right. Okay, we shall make sure that we answer all the questions on normal distribution next week, then before we continue to chapter 8. So next week we shall be doing chapter 8. I want to pull up so we know. So next week we will be doing chapter 7 and 8. And then after next week, we'll go on spring break. After next week, we shall go on spring break. By the time, before we leave, we shall be able to cover all that is in chapter 7 and chapter 8, so that when we come back, we will take the test. Okay, so throughout next week, we shall be working on chapter 7 and 8. Okay. All right, do you have any question? Any question? Uh-oh.